am Shayab Kumar Thar. Today I will discuss a very important problem based on functional analysis. It's a very important and interesting problem as well as, that is, if t from this space C101 to with respect to sup norm to this space is a linear operator such that t of f equals to f dashed means its derivative, then show that t is unbounded. Okay. Now, first of all, I am discussing few small things. That is, what is C01 space? What is C01 space? C01 space is the space of all continuously differentiable functions on 0, 1. Okay. And what is C01? C01 means space of all continuous functions on 0, 1. Okay. What is sup norm? What is sup norm? Sup norm means it is defined as follows. Like sup norm of f, it will be supremum of mod of x, where x belongs to 0, 1 here. Okay. And I have to know all of this, and first, at last but not least, what is norm? Norm of t. Norm of t is supremum of norm of tx by norm of x such that x not equals to 0. Okay. These are my few things, and t is said to be, and I am saying one more thing, it is t is bounded if and only if norm of tx lesser equals to lambda into norm of x for all x belongs to x for some lambda belongs to my field. Okay. These are the whole things that I shall use to solve this problem. Okay. Now I am proceeding towards solving the problem. Okay. Now, what I have to say that it is unbounded. I have to prove it. Now, just please take a function, a sequence of function rather. Let okay. I have taken few functions. It is sequence of functions. It means a set of functions, I can say like it, where n belongs to natural numbers. Okay. Then what will be its what will be the t of fn? What will be the t of fn? That will be fn dashed x. It is n x to the power n minus 1. Okay. Where n belongs to natural number and x belongs to 0, 1. Fine. Now, norm of t of fn by norm of fn, what will be its value? I am trying to find it out. Norm of t of fn, it means this one, it is n x to the power n minus 1, its sup norm or by fn, it means norm of x to the power n, its sup norm. Okay. Now, if for each n, okay, so now it will be like, it is proper from the property of norm, it will be like mod n into norm of x to the power n minus 1 by norm of x to the power n. Now, what will be this? What will be this? This will be like mod n into supremum of where x belongs to 0 to 1 mod of x to the power n minus 1 by supremum of x belongs to 0 to 1 x to the power n, its mod. Okay, now what will be its maximum value? It will be mod of n equals to n, because n belongs to natural number, it's always positive by default. Then mod of n equals to n. What is its supremum value? When x equals to 1, then it will take the maximum value. Okay, for each n, when x is 1, then it will take the maximum value. So when x equals to 1, then it will be 1 to the power n minus 1. It is 1. Okay. For it's also same. When x equals to 1, then it will take the supremum value. Because if it's less than 1, then its value will be lesser. Okay. When it equals to 1, then it will be, supremum will be 1 to the power n. It is 1. So it becomes n. Now, for tfn by norm of fn, it is getting n. And as n tends to infinity, it's going to infinity. But my norm was, that my definition of norm was supremum of this value. My definition was supremum of this value. Okay, my definition was supremum of this value. It was the norm of t. But I am taking few functions and it's going to infinity. So its supremum for all f, it's bound to go to infinity. Okay, it's bound to go to infinity. So it's not bounded at all. Fine. So it has already proved. To know more like this and more interesting topics, please follow and subscribe.